Hello, welcome to SanfordFlipMath. This is PreCalculus, and again, we are working from the Demana Foley Kennedy PreCalculus book, 4th edition, and just mention that for copyright purposes, the photos here on the pages are from that book. Thank you to all of you. And we are working on section 1.4a from that book, which is about arithmetic and actually composition of functions. So we're going to try and hit both of those ideas in this video. And arithmetic is fairly intuitive. Arithmetic of functions is fairly intuitive. And I know this notation can be a little daunting, but really all this is saying is if you see this notation, so it says f plus g of x, this does not mean, okay, so does not mean that you're going to distribute an x here. That is not what that means. This is not multiplication. This is a version of the notation like f of x, and I know this even looks like it got distributed, but it's really not distributing. You are not multiplying times x. Sometimes a shorthand version of this is just f plus g or f minus g, f times g. Please note that if it's f times g with a dot there, this dot has to be filled in, or f over g for division. Okay, and all the same domain and range concerns go along with this. So, you know, if stuff's in the domain of g and in the domain of f, then it's in the domain of f plus g, f minus g, f times g, f divided by g, provided that g of x itself doesn't end up being 0, because you can't divide by 0. Okay, so it's actually pretty intuitive, as I mentioned, and we're just going to go ahead and do some quick examples of this, and it's really not that big a deal. So, for instance, f plus g, according to that notation that was in the from the book. Pardon me while I clunk around here. F plus g is just f of x plus g of x, and you're almost never going to see me write that. And all we're going to say is f of x plus g of x. Isn't that deep? That's pretty much it. Just combine like terms as we can. So x squared, and this is going to be minus 4x plus 4. Wasn't that exciting? Just a quick little word of warning. If we're subtracting, be careful to do grouping appropriately. So like f minus g, so f of x is still x squared minus 3x minus 4 minus x. And so the grouping becomes important here because this minus, this subtraction, is about subtracting all of that. Okay, so this becomes x squared minus 3x minus 4 plus x. Okay, again, this is plus x because it was minus the negative x, or minus x. And I'll do a little combining like terms. And that's it. Now, there's nothing really sacred about f and g. For instance, if I wanted to do g times h, then I can just do g times h. Well, that was good planning, wasn't it? All right, so and then the issue is, let me rewrite that because it's kind of hard to see. Okay, now there are a number of ways to handle this, but in terms of simplifying, probably worth noting that this is like over 1. Okay, so I can treat this as 4 minus x times x plus 3 all over, well, 1 times 4 is 4, just following the rules for multiplication of fractions. And then you can distribute all of this, or as I know some of you have referred to, foiling. 4 times x, outer would be 12, inner would be minus x squared, and then last would be minus 3x. And combining like terms, so this, I always like my x squareds up front. You don't have to. It's just pretty standard to do that. And, excuse me, we are done with that. Okay, and then just one little quick example. Let's do j over g. And so if I do j over g of x using the other notation, a little more thorough notation. Okay, so this, what I'm going to be doing is j of x over g of x. Okay, so I need to run back up to find out what j was. 4x minus 3. And g of x, 4 minus x. And then the question is, can this be simplified? Now, I need you to resist temptation. It is so tempting to look at those 4s and go, bam, bam. Sorry, can't do it. Those 4s are not common factors. They are not connected to the entire thing. The bottom of this doesn't say 4 times something and the top 4 times something. This is 4 times x, not 4 times x minus 3. Or another way to look at it is, I don't have a 4 in common with all 4 of these terms, so I can't divide it out. Okay, so the quick version is, that's pretty much done. This is it. Okay, so again, arithmetic of functions is pretty darn straightforward. It looks like what it is. There is no big shock there. You just, if it says f times g, just multiply f of x times g of x. Okay, the big thing to watch for is some people try and distribute an x. Like for instance, that last one I wrote here. Some people would take this x and then try and multiply this x times this somehow, and that is not what you do. Okay, so don't do that. Okay. All right. Composition of functions has to do with putting one function inside of another. Okay. Now, before we do this, I just want to kind of remind you how this f of x notation works. So, like for instance, if I have f of x is 3x plus 2. Let's say I want f of negative 1. So this means that I'm going to go through, and everywhere I see an x, that negative 1 gets put in there. Whatever this is goes there. So this is now negative 3 plus 2, not negative 3x. This is now negative 3 plus 2 is negative 1. That's it. F of negative 1 happened to also be negative 1. Wasn't that a weird coincidence? Okay. If I have let's say f of x is x squared minus 4x plus 3. Okay, just as another quick example. And let's say I wanted to do f of 3. So I'm just going to, everywhere I see an x, I'm putting in this 3. So this is 9 minus 12 plus 3. This is really weird. Everything I'm doing is like a special case somehow. All right, so if using this same f of x, what if I was going to do f of a? Well, all that means is I just take whatever's here goes in both of these. So this just becomes, and most people would write that a squared minus 4a plus 3. Wasn't that exciting? Okay. Or, let's say I have, oh, I don't need to use f for everything in the universe. Let's say I have g of x is x squared plus 2, and let's say I want to do g of 2x. Well, this means I'm going to follow this pattern for the function, and whatever is in here, you guessed it, goes right here. So now I'm going to say 2x times 2x is 4x squared plus 2. Well, what if, okay, and this shouldn't be anything, earth-shatteringly new. This is really an Algebra 1, Algebra 2 concept. What if I told you that g of x was x squared plus 2 and h of x was 2x? And let's say I want to know what g of h of x is. So here's the concept. You take h of x, put it in there. and then do g of 2x. Okay, now you'll be shocked to know that I just did this problem. Okay, so again, this same 2x goes here. This is 4x squared plus 2. Okay, so this is called composition of functions. When you put a function inside of another function. Okay, the first thing that we were doing was arithmetic of functions, and that's when you do arithmetic, like you add, subtract, multiply, or divide functions. Well, this is composition of functions. One function inside another. The only catch in this, and again, none of this should be new. The only catch in this is that there are two different notations for this and actually variations on all of that. So this says put g inside of f. This says put g inside of f. Notice that that's an open circle. It kind of looks like the letter O or the number 0, but really it's more like a multiplication sign that's open. Okay, so I need to make a big stink out of this. This, with a closed circle, a filled-in circle, is multiplication. This, and I know people look at it and say fog, but it's that circle is really not as big as the G or the F. It's not as big as the letter O. This means composition. In other words, f of g of x. Okay, so the one that's closer here to the x is the one that goes inside. And there are some variations on this. It can be f of g of x means the same thing, or just f of g means the same thing. All of these notations mean the same thing. Okay? Not a big concept, but it's not trivial either. And let me just say, people make mistakes when they start going too fast. Okay? All right, let's do some more examples here. Okay, let's do f of g of x. Okay, I don't know what it is about f and g, which also is the same thing as f composed with g written like that. Still the same thing if I write that. Okay, so again, all this means is we're going to do f of g of x. In other words, f of whatever g of x is. In this case, it's 4 minus x. So what this means is we're going to go through f of x, and everywhere I see an x, I'm going to put parentheses. Now again, I've said this before, I'll say it a lot of times, this is I think the cleanest way to do this without making mistakes. If I just go through this function and say, well, I know it's something squared minus 3 times something. Okay, so that something, that's a technical word. Okay, no, I'm just lying now. Sum in. Okay. Okay, so something goes there. Now, the issue is, you know, that's like a spot to put something. So, and the something I'm going to put is this 4 minus x. And now it's just a matter of cleaning it up. I mean, technically I've done it. It's just this isn't a very good form to leave it. Okay. So just a reminder that 4 minus x squared means 4 minus x times 4 minus, that was nice. Yeah, that's not going to work. It means 4 minus x times 4 minus x. Well, I'll just go ahead and write it underneath. I know, sorry, the OCD people are all upset with me. There you go. All right, 4 minus x times 4 minus x minus 12 plus, okay, think about why that's plus 3x. Okay. Well, I need to do some multiplying here. So 16 minus 4x minus 4x plus x squared. Okay, and combining like terms, again, I like my x squareds up front, and then my x's, and that's it. So f composed with g for this function f and g is that. So keep in mind too that these functions could be different, and the idea would be, you know, problems in the book or problems on a test or something like that, they would have to tell you what those functions are for this specific application you're doing. Okay. So, all right, same idea. Let's do it again. Let's do j of h. Okay, so in other words, I'm going to do j of h of x. Most people are more comfortable with that notation. So this means j of whatever h of x is. Well, ooh, sorry, it's the F word. Fraction. You know what? Fractions happen. Okay, so here we go. We're going to write down what j is. 4 times something minus 3. And what am I going to put there? Whatever's inside j goes inside j. Oh, this is going to look nice. I'm excited already. Okay, well, 4 times is the same thing as 4 over 1 times. 4 divided by 4 is, you guessed it, 1. So this is now x plus 3 minus 3, which is x. Okay, so j composed with h, j of h of x, is x in this case. Okay, again, nothing sacred about, j of h, or, j doesn't have to be 4x minus 3 every time you see j. So don't memorize that thinking, oh, that's always the answer for this. Okay. All right, I think I got one more little issue that I need to make a stink about, and I'm going to go ahead and steal a problem that I did just a minute ago. Okay, so we're going to come back to f of g in just a second. But first, I'm going to do g of f. Okay, please note that's an open circle. There's a tiny little spot there. Can't really see it. Tell you what, I'm going to rewrite it because I just want to make sure it's clear. Okay, so g of f. Okay, goff. Yeah, I know somebody's going to say goff. All right, g of f. So g of f means g of f of x. Sorry, I scrolled down so I can see what the functions are. So g is 4 minus x. So this is supposed to be 4 minus, you guessed it, something. That something is f of x. Well, what's f of x? X squared minus 3x. Okay, so that was a quick peek. X squared minus 3x. Okay. Sorry, just to be complete. So doing my little subtracting the group here, this is going to be 4 minus x squared plus 3x. Think about the signs. Okay, one more. Negative x squared plus 3x plus 4. Again, I just prefer that order. Okay, so now's the time to make the big stink. Okay, look at this. And look at this. Okay, what's my point? Okay, so I want you to think about, let me scroll back just a little bit. I just want a little more room there. Okay. Think about things like 2 times 3 and 3 times 2. Negative 1 plus 4, 4 plus negative 1. Multiplication and addition are commutative, which means if I change the order, if I rearrange the order, it doesn't really matter. I get the same answer. What about composition of functions? Is composition of functions commutative? Well, that's the issue here. If I change the order, if I do f of g, this is what I get. If I do g of f, this is what I get. Is that the same answer? Okay, so composition of functions commutative? No. Okay, what's that mean? If we change the order of composition, we do not, sorry, I gotta pop the page again. We do not always get the same answer. Okay, so a couple ideas we talked about in this video. arithmetic of functions, which is very intuitive. Add, subtract, multiply, divide. Just be careful with grouping because sometimes you're like subtracting things that are added or subtracted, and then you have to distribute the minus. And also division, be careful with grouping. Sometimes you're making a big fraction. Composition of functions has some weird notation, but basically you're putting one equation inside of another one. Okay, that's it. We'll do more with this in class. Thank you much. Bye.